For the last 49 episodes, we have used computer codes to study physics topics. At the heart of these codes sits a simple method for updating position based on velocity and updating velocity based on force. But I never actually proved this method to you, I just used it as a given. This method works fine for most everyday applications, but it turns out to break down when we work with objects moving close to the speed of light. If we want a more accurate representation of the universe, we need to make one correction. And with humanity's continuing advances into space travel and reliance on GPS satellites, this correction is increasingly important. The correction starts with the relationship between momentum, mass, and velocity. It turns out that we need to add a number in here, which is nearly equal to 1 at low velocities, but is much different at high velocities. We'll see that this extra factor makes the object less responsive to forces at higher speeds, since it introduces the speed of light as a speed limit for the universe. This new strange behavior is called relativity. Here is our adjusted animation loop with a spring providing the force. The momentum updates based on the force, and then the position updates based on the momentum with this new relativity factor added. We'll also animate a second object that does not include the relativity factor as a comparison. By the way, to keep the numbers simple, we've set the speed of light equal to 1. This just means that all the speeds you see in this video are measured as a percentage of the speed of light. When we run the code, we see that our relativistic red ball falls behind the ordinary green ball. This is because of the relativity factor that makes it less responsive to forces at higher speeds. You can see this difference in the graph of each ball's velocity versus time, where the red ball must keep its velocity below the speed of light. Again, this is the speed limit for the universe. The green ball, on the other hand, does not have this restriction, and it moves in a cosine function as usual. We can see this difference become exaggerated if we increase the stiffness of the spring, or if we lower the speed of light. These differences are a strange feature of our universe, and you can learn more about them through the activities at the link in the description below.